All right, guys, here we are at the last set of notes for the entire school year. We're going to dig into the cosine function family, which you're going to see has a ton of similarities to the sine function. And actually, if you do what you're doing with sine function, you're going to see, guys, it's going to be really, really easy for cosine because really the only difference between sine and cosine is the kind of starting values of the parent function are shifted slightly. All right. Actually, they're going to look pretty similar, and it's actually almost impossible to distinguish a cosine graph from a sine graph if you don't actually know where the period begins and ends. So let's dive right in here. So we have our cosine function, and notice the good news, guys. Everything here is exactly the same as the sine function. There's absolutely no difference in transformations. A, B, C, and D, amplitude, period, the way we approach transforming the values on the tables, everything stays the same. What changes, guys, is in the parent function. Notice, when we talk about having a period in our amplitude, where we start and where we end are no longer x-intercepts. Previously, when you look at the parent function for tangent, when you look at a period, guys, notice a period began and ended with an x-intercept, right, on the parent function. So we went from x-intercept down to a minimum, up to a maximum, back at an x-intercept. With a cosine function, what we are going to do is the parent function begins and ends with a maximum. So we start at a maximum, we go down, we cross the x-axis, we continue to go down, we hit a minimum, we turn back up, cross the x-axis again, and hit a maximum, and then we end the period. So what that does is that changes some of the values on the x-axis where we hit max, mins, and zeros, x-intercepts and zeros, but really everything else we're doing is the same. So a couple of small changes here. You can see that our relative minimum is now at pi rather than pi over 2. Our relative maximum is at 0 and 2 pi, which is changes our starting value. But notice the way we did the rest of the ordered pair, excuse me, guys, the way we wrote the rest of the ordered pair is not changed at all. So same thing with x-intercepts. All that's changed on the x-intercepts is where we're actually crossing the one we're taking here as our first value. The rest of it's not changing. So I'm still, nope, I want that to be green here. I want that to be green, right? That's my x-intercept. This right here is my relative minimum that I used as my starting point. And I used this point right here, which is also the start of my period there as my relative maximum there. Amplitude is still 1. Notice that's we go up to positive 1 and down to -1. Period is still 2 pi. The midline is still y equals 0, the x-axis. Guys, pretty much everything else. Oh, the y-intercept. That was the other thing that changed. Notice the y-intercept is no longer at 0, 0, but it's been, because we're starting at a maximum, starting at 0, 1. All right, so tons of similarities between cosine and sine. The way we change the values is going to be exactly the same. So there's really going to be no difference here between sine and cosine in that regard. But let's do another example here just to make sure we refresh our memories. And the big difference you can see, as we talked about in the graph, is the starting values. You can see down here, these values, the range values for our parent function for the same domain values is 1, 0, -1, 0, 1, whereas with our sine function, they were 0, 1, 0, -1, 0, right? So that's really the only difference, guys, and that's what's going to account for the change in our graph between sine and cosine. All right, so if we look here, let's going through this, we see that A is -1/2, right? We can see that B is +4. We can see that C is actually positive pi. Remember, it's the opposite of what it looks like there. And let's go with a purple, and D is +2. So remember, A and D transform the y coordinates, the range, and they follow order of operations. So we are going to multiply by -1/2, and we are going to add 2. So if I multiply -1 by -1/2 and then add 2, I will get 1.5. 2, all right, and then we're going to have up to 2.5, back to 2, and then 1.5. What you'll notice here, guys, is notice the negative a value caused this to change. Notice the 1, 0, and 1, and 1, the 1 with, sorry, let me start that over. The 0, 1, and this 2 pi 1 were maximums, but now you can see they reflected, and that 1.5 is actually the lowest value in that period. Okay, so let's look at the domain values. We have a b value of 4 and a c value of pi. So remember, we're going to do opposite, the reverse order of operations. So plus pi, and then we're going to multiply by the inverse of b, so times 1/4. Again, for purposes of keeping the video short, I won't show you the work. I will do the work for the adding pi and multiply by 1/4 over here so you can see that. But if I add pi and then multiply by 1/4 here, I get pi over 1/4. I'm going to get 3 pi over 4 here. If I add pi, I'll get 2 pi, so this would be pi over 2. Add pi here, I'm going to get 5 pi over 4. And then if I add pi here, I will get 3 pi over 4. No, that's not right. Sorry. If I add pi, I will get... oh, I'm sorry, guys. I made some arithmetic mistakes here. This should be 3 pi over 8. I apologize. And I believe this should also be 3 pi over 8. And this would be 3 pi over 4. Because, yeah, that would be 5 pi. Yep, there we go. All right, so now we're solid. Now we're looking good there. So those would be my transformed coordinates in gray for the parent function. So let's just put it all together. We really don't need to spend a lot of time doing anything else because so much between cosine and sine is the same. So if we're working on the example here, let's find A. A is 3. B is 1. C is 0, and D is 4. And I think I just realized that these examples are, did I use the same numbers? We did use the same numbers. So we kind of were a little lazy there. So let's actually start on 3 here. Let's do one we didn't do before. Okay, so in this case, A is -2, B is 1, that hasn't changed. C is positive pi over 4, and D is 0. All right, so again, as we talked about when we worked on our sine, we don't have to worry about B, we don't have to worry about D, because they did not change from the parent function f of x, and we have to make that change here as well. This is actually g of x that we are graphing there. But we do need to make some changes here with A and C. Remember, A is going to be multiplied here, so this is times -2 and then plus 0. So this becomes -2, 0, +2, 0, -2. All right, pretty straightforward. Now let's look at the domain. Remember, we have to do the reverse order of operations. So just like we did here, we have to deal with adding or subtracting C first and then multiplying the 1/4. So I'm going to add pi over 4 and then, just to show you, times 1, even though it won't change anything. So this becomes pi over 4. This becomes 3 pi over 4. Now you do have to change and get a common denominator, like we have to work just like we've always worked with fractions. This is going to become 5 pi over 4. Oops, sorry about that. 7 pi over 4, and finally 9 pi over 4. All right, so now we've got our graph here. We've got our coordinates, we've got our graph, we can set this up. Remember that each of these boxes, since you can see this is labeled that here is pi, and there are 4 boxes between 0 and pi, each box represents a quarter, which will help us with this graph. So let's put these points here. So we have pi over 4, which is 1 box, -2. All right, then I have 0, 3 pi over 4. So 3 boxes, 3 quarters is 0. I'm up to positive 2 at 5 pi over 4, back down here. And then we're going to go off the graph just a little bit. Remember, this edge is 2 pi. So we're going to come right over here. Right about there would be 9 pi over 4. Right? And if you go off the coordinate, if you need to go off the coordinate plane a little bit, guys, to hit that last point or something, that's fine. On the homework, I did go through and try and make sure that you would have enough space and renumbered the coordinate plane so that you would have enough space no matter what. But let's just extend this period to the left here. So notice we went up to a maximum and then down. So we're going to go back up, cross the x-axis, go up 2 more quarters, hit a maximum, go 2 more quarters, hit the x-axis, and then 2 more quarters and come back down to 2. So we can see this pattern here developing. And so we can kind of just graph that. All right, and this smooth curve action we see going on here. All right, drawing this graph. And again, guys, I don't expect perfection in you drawing this graph, but I would like to see you try and make sure that it's curving the way a cosine and sine graph actually look when they curve, right? And let me just try and make that one a little better. There we go. All right, and so we've got our graph. Right? We've got our table of values. We've got our graph. Last thing we just have to work on is our characteristics. Well, amplitude is based on A, and since the A value is -2, the amplitude is going to be the absolute value of A, which is +2. Period. All right, period is 2 pi over B. Well, since B is 1, that is just 2 pi, and our period does not change. Midline is based on D. Well, since D equals 0, we know that my midline is Y equals 0. All right, and there you have it, guys. Notice that really nothing is changing in terms of how we approach these problems. Really, the only thing that's changing is where we're starting the period in our parent function, which then we talked about changes the range values in the parent function that we're using when we transform the coordinates on the table. All right, guys. Well, that's it. That's the end of the end of the year. The end of our video notes. It's been a great year. I desperately wish we could have finished the year together in the classroom. Trust me, even on our worst days in school are way better than making video lessons by myself in my house. So I miss you guys. I hope I get to see all of you next year at some point. Stop in and say hi. Maybe we can do some sort of AAT class reunion or something at some point once we all get back to school and there's some normalcy that returns. So stay safe, stay healthy, and please, if you got any questions, reach out. I'm here and happy to help.